Hello again, and in today's video we're going to be finding the equation of the tangent line. Now in order to find this, we need to use the point-slope formula, and we also need to find what x is equal, what y is equal to, and what m is equal to. Now in order to find m, we have to find the first derivative of this, but first we're going to find y. To find y, all you have to do is plug this 1 into the original equation here. So we get 3 plus 4 minus 5, which is 2. So y is going to be equal to 2. Now, m, we need to find the first derivative of this, and we're going to be using the power rule to find this. 2 times 3 is 6, minus 1 to the exponent is 1, and then plus 4, and then that's the first derivative. That's pretty simple. You just, because 1 times 4 is just 4, and then minus 1 is 0. That just gives it the x, and the 5 is just constant. So that disappears. Now, what we do is plug in the x into where that is. So that's 6 plus 4, which is 10. So the slope comes out to be 10. Now we just take these things here and plug it directly into the point-slope formula. So it's going to be y minus 2 equals 10x minus 1. And then this is going to translate to, we're going to distribute y minus 2 equals 10x minus 10. Then we just add the 2 over. 2, fix my 2's. And then looks like it's going to be equal to, y is equal to 10x minus 8. Alright, so this is the equation of the tangent line for this function right here. So all you do is just find x and y and m, and then just plug that into the point-slope formula. But to get m, you need to find the first derivative of whatever the function is. So that's that. I'm going to check this later. I'm going to show you later in Mathematica at the end of this video, that just to prove that it works, just as a visual, so you can see. So we're going to set up the next problem. Right now, let me erase this. Alright, now we're going to find one that's slightly harder. It's going to be f of x is equal to 3x squared, no, 3 times 3, hold on one second. 3 times 3x squared minus 2 to the 1/2. Now we're going to be using the chain rule, and you can go see my other video how to do the chain rule to find the first derivative of a function such as this. But I'm just going to go straight through with this. But what I always do first is I like to write out x equals, y equals, and m equals. And sorry, I didn't say where it starts. It's supposed to be at x equals 1. You'll always get either one of these points. You'll either get y or x in these problems. So you can solve for either x or you can solve for y, depending on what variable they give you. Alright, so might as well just find the first derivative first. It's going to be equal to, so we have 1/2 times that, which would be 3 over 2, times 3x squared, times everything on the inside, minus 1/2 times the derivative of the inside. So this is times 6x. Alright, now we're going to simplify that down here. F prime of x is equal to, let's see, what does it simplify to? It's going to be 3 times 6x. Then we're going to bring this downstairs because of this negative exponent here. So it's going to be times 2 radical 3, oh, it's going off screen, x squared minus 2. Sorry about my 2's. I forget you said this new marker. Alright, so we have the first derivative now. So x is equal to 1 here. You can just ignore that. So when we plug x into the original equation here, which we have to solve for y, we get, let's see, 1, looks like it's going to be 3. When you plug 1 into this, you get 3 for the y, and m is going to be equal to, let's see, 6 times 3 is 18, over 3 minus 2 is 1, 18 over 2 is 9, so slope is equal to 9. So when you plug 1 into this, this is the equals m equals 9, which is equal to that. Alright, so now that we have this, we plug these 3 points. I'll rewrite it here down here. X equals 1, y equals 3, and m equals 9 into the point slope formula. So this will give us y minus 3 equals 9 times x minus 1. So it's going to be y minus 3 equals 9x minus 9 plus 3 or equals y is equal to 9x minus 6. And this is the equation of the tangent line for this function up here. So all you have to do is find the first derivative. Actually, I'll explain it. First you find, you take whatever point they give you, plug that into the original equation. That will give you either one of these. You can either plug in x to get y, or if they give you y, you can plug in x, but most of the time they'll give you x for this. So then that will give you y. Then you find the first derivative, then you plug that x into the first derivative to get the slope. Then you just use the point slope formula to find the tangent line here. Alright, now I'm going to actually show you visually on Mathematica what this graph actually looks like for each one of the functions I just showed you. Alright, now I'm going to show you, or prove to you, using Mathematica, the equation of the tangent line here. This was the first function that we figured out, so I just plug that in. Then we take that x value to get the y, we just plug that into there to get the y value. So x is 1, y is 2, like I showed you. We take the derivative, and then we take that x and plug that into the derivative. That gives us 10 for the slope. And then we plugged into the point slope formula before to figure out this as the answer. And, oh, I already have it plotted here, but the purple line here is the tangent line, and this is the f of x right here, the blue. So that just shows you that that's truly the tangent line there. And on the next one, we have the other function that we figured out. Just going to enter that. Plugged in the x and got y is 3. We found the derivative of that, which I showed you in the written example. Then we plug that x in to get the slope of 9. And then we plugged into the point slope formula, point slope formula there to figure out this as the equation. And then, then we plugged, then I graphed it here already. The purple line's the tangent, and then the blue line is the original function. So just to show you visually, these are the two graphs of the tangent lines of both of these functions. Alright, I hope this was helpful, and thank you.